Yeah, I think I'm live. So let's continue our discussion on search engines that we were doing in last stream. Let me share my screen. Yeah, hope it is visible. So in the last stream we discussed a little bit about what is search engines and how do they work internally. And I think I ended this topic with a few questions uh, that I mentioned that I'll discuss in this stream. So let's go through each of them and discuss. So as I told, the data in the internet is very big. So you can imagine the amount, the data that Wikipedia and Google has. So for a word, each word you type in Google search bar, the whole concept of this ranking and stuff that I have mentioned, not ranking, the whole process of this querying the inverted index and fetching the results will be done. But there will be a lot of relevant documents that has to that has the information that you wanted. But only some indices has some documents as the act. But if you dump too much content or too much answers to the user will get frustrated. You have to narrow down the results that you are showing to the user. So for that, yeah, we will get to know. We'll get how to do that. The first question is regarding that. So the first question is how to limit the number of documents to show to the user. Before going to this, let's discuss about two things called as term frequency. Uh, Term frequency, as the name tells, it's how frequent a term or word appears in the document. So let's say, so for example, in a document where, for example, if you see this document, the document.py, we can search for machine. The word machine is present once, twice, thrice in the document one, and it's present once in the document two. Yeah. So it's a term frequency per each document. So how do we calculate frequency of a term? How do you calculate frequency of anything? It's a bit simple. So let me denote with TF. The formula is simple. The formula is like simple. Number of times term appeared in a document by total number of documents in that index. So this is what actually frequency formula, right? Because yeah, this is what is the frequency formula, and each term has a TF score per document because terms the words in each document may vary the semantic meaning and the meaning the intent of the information in that chunk. Yeah, this is simple. And one more term that you have to know, sorry, one more definition that you want to know that you should know inverse document frequency. So this is like how rarely a term appeared in the document. I think Gemini suggested as the formula. Let me see to the formula. Log of total number of documents in that index by number of what? Total number of documents in that index by. No, isn't it the numerator and denominator is same? This is wrong. Yeah, this is usually denoted by denoted by IDF. So input document frequency. Mm, Even I forgot the formula. Let's see in the Google. So it's like 1 log of n by, okay, n by d of t. So basically, n is number of total documents in that index. dt is number of documents in which term t is appears, not appears, present. Both are same, but yeah, meaning wise it's okay, anything. Yeah, and so let's say if you want to say if you want to find idf score of a inverse document frequency score of a term, right? If you want to find so let's say there is a term called as um, panini. So panini is a term, and out of all the documents which are available, it's not present in any of the documents. In that case, dt is 0. But panini, in this case, d of t is 0. If d of t is 0, log of this will be undetermined. So usually to avoid this case, so what the formula can be changed is, yeah, I think you guys got it. Just add 1 to the denominator so that it doesn't, it will never be 0. And anyway, this is always greater than, okay. And this always, d of t will be always greater than or equal to 0, right? Because it cannot be negative. So this is the formula of TF-IDF. And yeah, like how they come up with this, it's like a mathematical professors and researchers sitting in the labs and doing some research work. So yeah, that's how we got that. And yeah, I think it's intuitionally, this is like intuitionally derivable, but how rarely a term appears. Yeah, I think this also appears intuitionally. It can be approached like intuitionally, saying ki, this is the rarity of a term, but I don't know why logarithmic is a measure of that. Even I'm not sure. So should be chill. Okay. Now to answer the question, how to limit the number of documents to show to the user. So if I say there are this many books that I'll be giving to you, I'll be giving, let's say, 250 books giving to you. So you will say, no, no, I don't want 250 books. I want 50 books. So I will ask you, okay, what 50 books do you want? So you will tell some properties of a book, saying that that book should be minimum this much thick, this much length, and this many number of pages. The first 50 books that cross this barrier will be given to you, and remaining 200 books doesn't matter because you only wanted 50 books. So we need to sort of give a rank to documents. Yeah, obviously it's based on user query. And how does every search engines or every search engine implementations rank these documents, rank these the results of user query uh, differently? They handle that differently. One most common way is that TF IDF score. So what is the so okay. So I'll tell you the formula of this TF IDF score. It's simple. So TF IDF score is, yeah, I think it's also super intuitive. Just the product of term frequency into nudge document frequency. So this score, if you return this score in a descending order, the highest TF-ID of when you do a keyword query to Elasticsearch or something Elasticsearch index, you will get some results, and the first document will most probably you are the most relevant, most closer to your user query. Second highest, third. It goes as the TF-ID of score decreases, the relevancy of that document to your user query to your query decreases. And why is it so? Why TF-IDF is considered as one of the score? Because let me tell you, I'll show you with the. There are two things for two requirements to meet for good results. One, there is a document which has which appears the word which there is a document which has a word which appears more number of times, so there is a more probability that since the document contains the word that you wanted to see, like maybe your word from your query, since it's appeared more number of times, there is a more chance that this chunk might contain relevant information that you want to see. Yeah, again, like since stopwords cannot be dynamic, that's one of the biggest task in NLP. um, as a data can be varied, data will be never be static. Yeah, is that a right statement? Yeah, data can never be static. You can get any form of data, and from the data that you're how much from the data that you process, you cannot come up with the stopwords, because stopwords are identified once you after you querying the data, or after you seeing the results of the query, something like that. I think that is how I have been dealt with stopwords at my work. So yeah, I think there might be another ways or some other techniques also to identify stopwords before without directly querying and more narrowing down the results. But yeah, that's one of the way that I follow at my work. So that's why I always make your stopwords dynamic, maybe as in one variable or something like that. So yeah, the intuition is the search word or a term should, if it appears more number of times in a document more number of times in a document, the probability is that that document will contain the relevant information. So let me write down, if term is present more frequently in document, then there is high probability that, so again the documents relevant to your user query that you are fetching retrieving is based, everything is a probability. um, Programmatically we cannot pinpoint to a specific document that has your information. Maybe no single document can have the entire user queries information cannot be fit in a single document, because all these documents are pre-processed and stored way before you queries comes intuitionally. But yeah, it's again the probability and guessing or bringing up more most relevant chunk as an answer, assuming that you will have the chance of getting satisfied by the chunks information. As that said, that the word probability plays a big role there, and and this being a probabilistic or chance based retrieval or whatever, we are handling that chance based by a program, by uh, code that we can write, correct? So if the term is present more frequent in a document, there is a high probability that this document might contain relevant info as per user query. The second one. So if you have a term, let's say term A in user query, and it appears only, let's say, and there are 100 documents, and you have a term called as pistachio, yeah, pistachio, and pistachio is present only in the two documents out of all 100 documents. So the question is salted pistachio, and salted is the most frequent word in every document. Let's say let's say the document has information regarding salt march or salted peanuts or something like that, and the word, and your question is, your query is just salted pistachios. This is your query, and since the word, if you only rely on term frequency, the word salt, since the whole in the group of documents here representing about has a word salt in each of the document, you cannot completely rely on term frequency. And the second word in your user query, called second term in your user query, which is pistachio, which is present very rarely in the documents, let's say 2 out of 100 documents, and there is a more chance that these two documents can give you the better answer where term frequency is failing, because I think that's how it's intuitionally works, right? So yeah, if a term appearing rarely in the corpus is nothing but, no need to, all these, I observed something is, in this tech there are weird different and weird new words that appear, but deep down, they are known to, maybe you might have heard about it earlier, or you might have had an idea about it. It's just a naming thing. If a term appears clearly in the corpus is nothing but a set of documents, and I have already told documents is, what is wrong with spelling documents? Then it's more likely to be relevant to user query. Let's justify what I am telling, right? So we should try out something. So let's say if I search Euclid theorem, this I have searched many times because to solve some of the DSA questions. And yeah, this is my search query, and Google might have taken these two words, and if you do stemming, you can see my earlier stream. This, if you stem this, I don't know what will happen. I think it will remain as Euclid since it's a noun. Same with the theorem, since it's a noun, it will remain as this theorem. I think it's REM. Yeah, like whatever, you'll get the same thing. Um, these are the results. This is one entire document, and this is one entire document. Maybe this might be a chunks of documents appended, or this something like that. This, so each link that you see is a document here, and if you see, there are multiple results. Let's say starting from here, 1 2 3 4 5 6 7 8, and so that's what I'm telling. So if there are 250 results, do not show all 250 results to the user. So user is only interested in the top results, because I think that's how it works, right? So even if you go to 10th page, you might see some random things, but random links, but I don't know whether if these are relevant or not, right? We'll see, we'll come to that. Okay, so go to our first page. Let's open the most relevant Wikipedia article. This is a Wikipedia page. I have no idea. Yeah, I have seen this earlier multiple times. As yeah, it's to understand this. So yeah, but shit. So what are we discussing over here? Term frequency, right? So if I search about Euclid, it's appearing 33 times in this document. So let's make a note of this. Euclid is appearing 33 times in Wiki. Let's keep like this. So maybe I think this should be fine. Yeah. So if I copy the same word, and if I, oh, sorry, my bad. And if I go to this our second result, and if I go to my second result, this is again some random some math thing. So if I paste my Euclid thing here, if you see, you would appear on it 12 times. Appearing 12 times in random math page. Result 2, like rank 2, sorry. Rank 2, right? So same thing, let's search in the third, this thing, third link. No, this is the second link only. Let's search this in a third link, right? So if I do for Euclid, yeah, this came 67 times. But still, yeah, we'll just make note of this. Appearing 67 times in textbook. Rank 3. So let's go till rank 4. I think nothing to lose. We'll just get more clear. Yeah, Euclid appear only 4 times in this. Interesting. Appearing. What is this page? Cornell University. In a CU article. Rank 4. Now let's see the word theorem. Yeah. So let's go back. Let's go to Euclid and let's search for 0. Okay, REM. Okay, it's appearing 55 times. See, guys, have you observed it? Appearing 55 times. Why we got this minus? Okay. Anyway, never mind. I think this remain. I observed this search is remaining same for different websites. Let's see. So if I do command F now, theorem should automatically come. Yeah, see, 17 times. So let's go to our third rank. We'll see how many times theorem is appearing. 3 times. Good. See, here rank 3. Okay, let me come to this. 3 times. So let's go to the final one, Cornell University thing. We'll see how many times theorem is appearing. Theorem is appearing 4 times. Great. So now we don't know inverse document of IDF of these terms, right? Because of maybe like I don't know, because I have no idea how rarely this might have appeared. But inverse document frequency will be very less. If their search engine is grouped, documents are grouped by something, because it doesn't make sense to traverse through entire Wikipedia data, right? They might have shard the data or divide the data, both are same, divide the data into different things, or based on, they might have grouped the data based on something, right? So let's assume IDF is negligible because it's a rarity. It would have appeared very rarely in entire documents. IDF is rare, and why IDF is rare? Because both terms are meant to be frequent. So let's say, for example, there exists nothing called as Euclid ice cream parlor or Euclid beauty parlor, right? Because there is the in the real data, wherever Euclid is there is a term called as theorem. So I think that's why I'm telling IDF is there. But yeah, we will see about IDF in the code, how to implement that. Term frequency is freq. If you see the cross time of this rank 1 is 55 into 33. rank to 17 to 12, 3 into 67, 4 into 16. It went wrong here. It's like 4 into 4. Yeah. Now you can see why our Wikipedia appeared as a rank 1, math page appeared rank 2, textbook appeared rank 3. These are all decreasing order of these values, right? These are all actual ranks of these values. So that is why they appeared results like this. And this is TF-IDF is not ultimate measure for ranking. There are many aspects and properties which researchers did the work to prove what actually matters to relevancy. Relevancy, right? So why TF-IDF? Because those two are very famous properties and it's pretty much available in internet, and I have read about them. I read the articles also where I read this TF-IDF score. Now, the second question, let's see what um, we'll discuss about. Okay, what contributes to accuracy and efficiency is same thing. Relevancy matters. How relevant the return chunks, return documents to the user query, how closely they direct towards the user query or they align towards user query, and yeah. See, if you see Google search, Google results, there is no guarantee that for user query, whatever the link I get here, so maybe if I append here Euclid uh, resort, resort. See, this there exists. I think there exists no resort called as Euclid resort, but still, as a user, I can search anything, and I don't expect I expect the search engine Google to return the most relevant answers, but still it returns some of the answer. If you see this is the most relevant answer according to Google, let's see how relevant is it. So this is Euclid Historical Museum is I think a museum which has things related to Euclid, but it is showing the okay, wait to sign in. It is showing the intention of this document is to show resort near Euclid Historical Museum, but this doesn't contains actual my search results. If I do Control F on resort, see 33 is a term frequency. If I do same for Euclid, see 49 is its term frequency. That is why this got as more relevant and did not at all do anything to this search query. And as a user, if I click on this, this is now this info is presented to me, right? I should decide whether this is contributed to my answer or not. Since whatever my intention is not present in this search result, I will not go to the second one because second one will be more worse. If you see, okay, let's see what is this. Okay, why is it coming like this? Yeah, this is Euclid. See, and the name of the property itself is Euclid. Euclid is located in Seoul city, something like that. And if you see second one, okay, this is entirely this is a this full Make My Trip website is of this result is just to show a property named Euclid, and this is an Euclid Historical Museum. Maybe this might be something. This might not have contained the word Euclid at all. See, this doesn't contain a word Euclid at all, but this might contain a word resort. See, this again, guys, like this is pure term frequency, inverse document frequency, and this is a live example. See again, Euclid is a place, might be, or a group of hotels. Hotels near Euclid. This is also a place. So if you go down, the term frequency, inverse document frequency score will be reducing. That is how these are shown to you. And yeah, the question number one, does the most point number one to be noted, writing notes. Is it guaranteed that rank one document will have answer to user query? Is it? Does it have info? Rather than answer, I can tell information. Will have information to user query. Is it true? Is it always true? No. No means not guaranteed. I have shown you the live example why it's not guaranteed. So it should be clear, I guess. Again, the next rank documents, docs. It's better to represent as docs. From rank 2 will be more relevant because rank 1 itself is more relevant. How come we cannot expect rank 2 to be more relevant to the answer? I think that is where the probability picking up and assuming that this is more closer to your info. If that is failing, how come next chance or next probability document will have the more information? So this is one of that, and I think I answered the first and last question. Oh, the second question is middle question is so fun. Yeah. Okay. So how does inverted index in real life? Real life means like the real software things. Maybe Elasticsearch or maybe some any search index, right? Any search bar, any search engine that you have seen. How inverted index in real life built? Um, okay. Why the step goes? Okay. We have seen in our earlier stream that inverted index is just map of okay. Our earlier stream inverted index is just map of what is it? What is it? Is this string and not list, guys? Set off because what if a word appear multiple times? Set of integers multiple times in the same document. Yeah, this is the inverted index, but since we need to have the frequency of the term, and as I mentioned, as we saw in the code earlier, we were declaring this as a list earlier and we moved to set because the list might be increased. Let's say a word called a vapor has a frequency of 100 in document 0. This list will be 0, 0, 0, and so on 100, and then the next list will start get appending. So that's not we want, and list should not be so big to iterate. So that's why we made it set. And you can ask Jashan, how do you find frequency there? That I'll show you in the code. Now the in real world, in real life, we store so many things in inverted index. We store term, its frequency of term in the document. Offset, guys, like it also matters where the term is present. Offset of term in the document, and obviously document ID. Again, offset of the term in the document is like at what position. Offset is basically a position. Again, it's like again, if I told you position of term in document, it would have You already know that, like, but offset of a term in the document makes you think like, oh, what is offset? What is the new thing? But again, like, it's nothing but a named thing. So let's see that, for example, and I think many more. This is what I have researched and got from the famous articles and stuff like that, and LLMs also. If you are interested and if it is open source, you can go to any search engine and you can see their code, how they're implementing this. And many more properties, right? Let's see implementation, right? Uh, so this is our document. I have shown this in our previous stream also. I think it's a list of JSON objects with some keys and values. Basically ID, title, and text. So couple of libraries and some import statements just to work with. Um, these are the common stoppers that I have shown you. So this is a class that this is one of the class guys that's I yeah. We initialize the stemmer. Again, this is a Python inbuilt library for stemming the tokens, and this translates the string and removes the punctuation marks and any exclamatory mark, some uh, unwanted apostrophe, something like that. This we have seen. So we are replacing underscores with this, and hyphen with empty space, and we are lowering the text into lowercase and doing translation over that, and we are splitting the clean text because each token is a word in that. So for each token we are stemming, and if the stemmed word is not in common word, we are appending. If it is present, we are just passing. This method just returns the final token, guys, after processing. Now this is the important code key, what actually we are building it here. So if you see, this is the structure. So for each term as a key, again the value is a dictionary. In this dictionary, the key value is doc id, key is doc id, and the value is again dictionary. In which key, this is like basically nested dictionary, guys. It's little bit difficult to put out in a single line, but you can understand each term is associated with the document ID, and each document ID is associated with frequency of that term and position of that term. So yeah, this is like they initialize the default dictionary with the index, and this is document metadata, which is now empty. I think maybe it's used to store frequency of what. Let's see, but yeah. So we are initializing this preprocessor also, and initial number of documents are 0. So this is the add document um, method, which take doc id and text from this as an input. And for each document that we are calling this in a loop, we are incrementing the number of documents. I think that is how it works. So we are processing the tokens that returns the token in each document. And in the doc metadata, for each document ID, I think this is a dictionary. In each doc ID, we are adding number of tokens. Um, yeah, to count the frequency of that. Next, okay, for document term in tokens, okay. Where is index that we deployed? Okay, this is okay. What is term here? Okay, after tokens, what is the output of tokens actually? Where is tokens here? I think tokens are here. Pre-process this. what are we getting tokens as, guys? The list of tokens, sorry, list of words, and we are appending that list of word to this index for each document ID, and we're incrementing the frequency also. Okay, this is the idea of formula. Again, if you see, it is 1 plus document frequency, because what if document frequency is 0? The log should not fail, so it's that. Next, this is a method that I'll explain. Okay, it's a result. Okay, this we can take it now. So we are pre-processing the query, because I have, as I told, thumb rule. Whatever pre-processing you've done for your data, you should do the same pre-processing to your query as well. So we are initializing a dictionary of score, and for each token in query tokens, for each word in the token, if the token is an index, I think if it is matching in the term, this term, inverse document frequency is that I'm passing this token. And yeah, if I pass this token, it is getting I think the count of this first one, frequency. I think that's what it needed, right? So it's calculating that, and for each document in the posting dot items is this this frequency. I think it's adding up the frequency. Yeah, it's calculating the frequency, and term frequency we got from the value of the this pair in this, and we are multiplying with the inverse document frequency score that we got for each token, and we are just adding each document id ka inverse document and the score of this, like tf id for each doc id in the score. We are sorting the score in the reverse order, so that the highest score will become first. Again, here this is like, let's say, assume this all are the classes and stuff like that. So this is the actual call to the services, or like this is actual usage of inverted index. So I'm creating instant of this, and for each document I'm adding the document into pre-processing step. So this does the pre-processing. My query is machine learning models classification. So if you see, the query tokens are this: machine, learn, model, classif. Classification is termed into classif, models are model, learning is termed into learn, machine is termed into machine. MACHIN. So see, this is the one, and document ID is one, and this score is 17. Yeah, again, this is calculated by term frequency to document frequency, inverse document frequency. If you see the word, maybe what's the word? Machine. Let's search for only this. 11 is its term frequency. Inverse document frequency will be log of 1 by number of, in how many documents this appeared? 1, 2, 3, 4, 5, 6, 7. Maybe log 7 to the base 10. Yeah, into 11. That's why, that is how this answer is 17.9. And the second rank goes to document ID 0, whose score is this. And this is the thing: if I'm showing this to user, maybe I would have kept threshold as 10, and I would have shown this first 4 chunks with document ID is 1045. So yeah, that is how the re-ranking works approximately. Exact re-ranking, we are not doing it. We are not calculating the position of the each thing, how it happens in real life, because it changes from provider of search engines. So yeah, I think that is it about the search engines, and I could share all the information that I have little bit taken from the articles of Medium, and many LLM prompts, and yeah, and so I'm actually interested in this searching part, because I think every engineer has some of the one of the interest domain where apart from work the engineer tries to go and learn about the things in that domain. Maybe it might be databases for you or some other thing, right? Maybe APIs or maybe network protocols or something. For me, what excites me a lot is search. So I'm so whenever because search is the most used thing, right? Like if you open Google Maps, you search for location. If you open Book My Show, you search for movies and filtering among the results. So 90%, not 90%, most of the time retrieval happens in most of the software applications. And it's not because of that, but I don't know, somehow I got hooked up with that search thing. So I'm very much interested in information retrieval. So yeah, this is about search engines. And yeah, as currently I'm exploring about how different types of searches exist, such as um, visible, fuzzy search, phonetic search, and approximation search that I have been doing, exploring in the semantic search thing. Semantic search is one of the search, and yeah, binary search. These are all normal things, but as a college graduate, if you say about search, you will think about binary search, linear search, and maybe heuristic search, few more like this, which you might have heard. But these are actually keyword search, semantic search, and phonetic search are different things that there are many applications based on that. And yeah, in my upcoming stream, I'll be talking about how semantic search works and I might not go into why semantic search matters because that's more like read and get to know part of thing. You have to read and you'll understand. It takes many streams to do to tell why semantic things is relevant and how we can make use of that. But the whole but number one, I don't have that much knowledge on semantic search. I'm still exploring. And number two thing, right, like there is a small difference between basics and fundamentals. These are fundamentals. If you see, there's nothing unknown in this. The only difference between me as a person who have a light idea about search engines and a person who doesn't have idea of search engines is just the reading part. I went out, I read through many sources, and this is the information that I gathered. Maybe I wouldn't have, I may not be able to put all the information because I don't really prepare for these streams. I just do it randomly, whatever topic comes to my mind that day. I'll try to do that. It's not like I'll prepare everything and I make note of it, then I want to discuss it. It's because the purpose of the streams that I'm doing is different. So it's not for that case. And yeah, it's like, and these are the things that I will be to be frank, these search engines I explored in the mid of my internship where I started first time working with Elasticsearch, which was way overwhelming for me because of the abstraction it is. Actually, this is the fun, guys. Like, abstraction is meant to hide things from the engineer and makes lives of engineer better. But I think it's a personal vision. How do you see it? But for me, abstracted things I don't enjoy much. I don't enjoy it much until I know the internals because I don't know. I don't know the reason behind that, but I don't enjoy working with abstracted tools or abstracted concepts until I get to know the internals of it. Now, since I little bit explored in the past 6 7 months around Elasticsearch and how search engine works, if anything comes up in the work related thing regarding this information retrieval, I can put out my thoughts and I can better reason why results are like this for this particular query. And what we can do to better the results, because I know how, what is the properties or what are the characteristics of a high ranked chunk or high ranked document. So I think that's how it helped me. So I enjoy doing these things. So yeah, the next thing is about semantic search, and it's going to be fun. I'll try to do it in a single stream because these streams I won't be able to do in a weekdays because I'll be occupied with my office work. As there also we are doing, I'm doing so much of interesting and interesting stuff. And yeah, I'm working there with the abstracted concepts only, abstracted tools and libraries. I'm exploring those also, how it works internally to understand better application, to understand the application better, so that we have control over the application and we know the limitations of the application. So yeah, next stream is about semantic search, and and now from weekdays, I'm not sure whether I'll be able to do a stream or not, but weekends definitely yes. Yeah, and I'll share this entire document. Last time I didn't share because I wanted to share once this is completed, and I will share this um, re-ranking document and also the inverted basic inverted index implementation that I have shown in the last video. So let's close this tab. Close this tab. How much time happened? 15 minutes. Yeah, let's. As I actually I shouldn't have mentioned this in the title. The title says the weekly contest. Also, I'll discuss, but it's a bit late for me already. But yeah, since I have told, I have to discuss about it. Yeah. These two I'll upload in these three document, those two Jupyter notebooks, and this I'll push it to repo and I'll share the link in the description or comments. Um, yeah. So I have given weekly contest today, and let me create a folder, guys. Work should be visible, at least if not for others, it should be visible for you, so that if the time comes when you question yourself, this will give answers to that. So where is contest C? So this is D. I think this should. This is A. Okay. Let me DSA. Oh, yes comes after O. Okay. Doesn't matter. No, not this. So the I think the folder name is streams. Sorry, not work related. Pictures, personal projects. Is it inside personal projects? Streams? No. Where did I? Yeah. Yeah, I found it. System. So today, what's the date? November 30, right? Let me open this in our favorite, not favorite, a new ID called as anti-gravity. I should really work on organizing this. It's totally messed up, but it's fine. Okay, let's close this. Let's close this. Not update. Yeah. And think this might be. What is this one? Fenwick tricks. Okay, not related to the stream, but still. Okay. I think today is weekly 478. Okay, weekly 478.txt. No, it is not working. Okay, it's proof, not this. In .txt, I usually write my proofs. So this is not the topic. Is it 478? So let's see. Yeah, it is 478. So this has four questions. Uh, this has four questions, and if you see pointers, right, like how, what is the points of each question? So 4, 4, 8, 5, 13 plus 6, 19. 19 points. It's like 4 plus 4 plus 5 plus 6. Yes. So it's distributed as medium plus medium plus medium plus hard. So usually the first question will be easy plus medium plus hard. But I'm surprised today a little bit. It's three mediums and one hard. But actually, um, I want to discuss some paradox. And the paradox name is JEE paradox. Yeah, this is a three-letter word that gives trauma for everyone, including my friends who did very well in JEE. So it's nothing. So easy the JEE paper, more useless it contributes to rank. So for example, if you see this contest, so I managed to solve three questions out of four, which might sound oh wow very wow by the fact that they lead code started doing this contest very hard. I think from last January, maybe to increase the level of this and some other uh, aspects we really don't care about that until unless they're giving constantly giving us problems. So the contest is pretty easy. I'll agree because I solved three medium questions. If you see the ranking, I don't want to show my ranking. It's so bad. The two medium questions, 8 pointers, I was able to solve in first 17 minutes. And if you see the third question, I solved by 56 minutes. So I almost took 15 minutes for question three with 10 minutes penalty saying the two incorrect attempts. So it's like 17 minutes for two medium questions. 15 minutes for one again medium questions, two penalty. So let's see what are these questions and first two questions I don't much discuss about that because those are easy and intuitive. I'll just tell the thought process. Question three I would like to discuss more about it. Um, so if you see this, the first time this is my IDE that I use for this thing. So if you see the first um, I was like sort the array. Okay, I didn't come up with this, but I started seeing entirely different thing. First thing, the golden rule that I have seen this over the internet. The three rule in TSA. Write down what's asked. I think what's asked in the question. Pick up relevant DS or algo for the question. Third one is simple. Nothing. No need to write pseudocode test and all. Just simple. Uh, Convert your logic into code. That's it. I think these are the three steps that usually people you see. I mean, like these three are so obvious, but um, if you ask the difficulty of each steps, why each step? Because we are just ordering it, right? So one is more difficult, then two is more difficult than three, or one is more difficult than three is more difficult than two. Sometimes you will pick up the data structure and specific algorithm easily, but it's little difficult or not that easy to convert this logic into the code without any errors in the first attempt. And in the contest, so what happens is when you hit on that submit button and in some test case fails, number one, they will not show the wrong answers input case. And number two, or will they show? I didn't observe. I think they won't show because answers are hidden during test cases, during contest. And every wrong submission will give you 5 minutes penalty. So here I did two incorrect attempts on. I tried to submit this question three times, and in the first four times actually. In the first time, the run itself is given one error, and I rectified that. The next two times, given I got wrong answers, so 10 minutes I was pushed back. So if you see, I entered the contest at 56 minutes, but my finish time is 1 hour 6 minutes because of that extra 10 minutes that comes because of this. So yeah, it's a little bit hard to write um, correct code, correct code without any errors. Sometimes with your logic, and this is the most important. And I still struggle with this step, asking what's asked in the question. This is so simple, right? Write down what's asked in the question, but that's what I think solves the 30% of the problem, because this question, if you read the question carefully, there is you can pick it up. So you can come to the point. So this line is the most important part of the question, and I overread it and I wasted some 5 minutes in wrong implementation. That's what led me to uh, like this. So but then the thing is simple. So you'll be given a nums. So you can write that. I know it right. I know to read question also. Today morning I read it. Given array nums, return number of elements whose frequency is at least k. Whose frequency is at least k, is it? Or okay, no, it's not related to frequency. My bad. I'm taking back my words. I don't remember the question. Okay, why not paste it here, right? K elements that are strictly greater than it. Okay. Return number of elements. Um, Return number of such elements. So what we can do is sort the array. I didn't thought about the brute force implementation because mostly the first questions will be easy and you will reach to the optimal solution directly. Sort the array for each nums of I. Find a number. Find index. Why it can like this? Find index whose nums of index is greater than or equal to k, and find minimum of this. I think this is also called as upper bound. I'm not sure. I'm very pretty bad with terms. But yeah, so let's say if this is mid, if this is index, then if total there are n elements and index you are at index element and if is greater than or equal to k, that's it, buddy. I just increase the answer and I think you are good to go. If you see code, I think it will be easy to understand. So first you sort the numbers and as a typical binary search, do left and right increase initialize this. And this again typical binary search template and whatever I have just told you, n minus the index will be if it is greater than a k, increment answer and return it. So this is the simple question, and yeah, I could come up to this little bit after multiple times reading of the question and understanding the questions clearly. That's why I said that the hard part is in step one is the hard part already. Hard part always. Let's see question two. How to close this window? Okay, this looks so weird. We have layouts. Okay. What if we don't eat? Nope, we don't want agent here. It is useless. Never improve anything. Yeah, it's chill, right? I think. Yeah, I think now it's good. So, yeah, so if you see this question, your given string is whatever it may contain, right? Lower level or upper level doesn't matter. Given string is return integer denoting maximum number of substrings you can split such that each substring start with a distinct character. No, Gemini, you tried hard, but still. Return max splits that can be done to s such that substring first character of substring obtained in each split is unique. So for example, if my string is A, I cannot split it here because the next substring, wherever you break it, it starts with A and end with this also starts with A. I can split here. This is one of the valid split, and I can split here. This is one of the valid split. Now, valid splits are A plus B. Let's change this also this and C. If you see there are two valid splits, plus indicates the valid split, and so yeah, this is invalid split. A B is this thing. And one more invalid split is let's say you don't want to break at B, so let it be AAB plus C. In this case also, this is A not equal to C, so but this is only single split, right? But they asked us to maximum splits, so this is a valid answer. So the thought process is again it's intuitive basically. I got it intuitively, and I kind of solved not similar kind of questions, but some questions involving this kind of intuitions. So it's like for each character, if not seen previously, mark it as seen and move on. If else increment count. So so like for let's say you're at the current index A, let's say you are at A, and you already seen A earlier, and you will not break it here. If and move on. If seen, if it is seen, it's move on, right? If seen previously, mark it as move on is not needed. Move on, else, else, mark as seen and increment answer. Yeah. So let's say in this case, A will be marked as true. Next case, A will be sorry. This is not a valid split. This is a valid split. Next character is A. Since it's already marked as true in the lookup table, I'll not do anything. I'll go to B. Since I have marked this already true, I'll increment to 1. B I have not seen because there is no previous B, so I'll mark it as true and I'll increment to 1. C is not seen in previous, only A and B is seen, and C is also, I'll mark it as true and increment to 1. So answer is 3. If you see the code, question 2, right? Yeah. If you see this is the code, if the string length is less than 2, I think there will be only if string length is this, right? So let's say A B or A, there is only one valid split, right? So either there will be only one valid split or 0. Yeah, 1 or 0. So if n is less than 2, return n and create a boolean array with size 26. Same thing, get the index of that. If already seen, do nothing. Else mark it as 2, increment count, return the count. Second question is also simple. Third question is what little bit took or ate my time in the contest. Yeah, again, I've seen if you see the leaderboard, people who are good at CP, they have did this question pretty quick because yeah, it's observations based question. So the question is simple, not simple actually, but still. Okay. Comparison by this question. Okay. Okay, let's ignore that, right? How to ignore this? Yes. So yeah, minimum absolute distance between mirror pairs. So it goes like this. Given nums, there are mirror pairs in array. Give min of diff of their absolute indices. So okay. So mirror is it's better to show example. So 12 is 21 is mirror of 12. If you reverse 12, you will get 21. In the vice versa, if you reverse 21, you'll get 12. Let me in the submissions. Let me show you the brute force which got me TLE. So this is basically a template code for checking if the number is palindrome or not. There is nothing much logic in that. And yeah, I'm storing the current scene integer and list of integers which are typical um, mirror things. So I'm just loading up the map here, and for each nums I'm reversing it. And if my map already contains reverse, that means my nums of I and my the map that has reverse are both are pair of reverse thing. And in that pair of reverse, I need to iterate through each index, and I am finding the difference because the reverse numbers, the array might be like this, right? If the nums is 12, 21, 21, 21. In that case, for 21, uh, okay, let me write like for key 21, value should be, what should be the values? Is it like this or this or this? I'm not explaining the correct answer. I'm just coming up the solution wise. If you see this, um, till here is my first attempt, which gave me a wrong answer. If you see the first wrong answer is because of that. And then I observed some more observations. This gave me TLE. And again one more observation. This gave me again wrong answer while running. And again here I haven't written much because I have observed this, so I directly coded. It got accepted. So yeah, coming to this, so it should be 1, 2, 3, right? Because we need to see which gives the maximum difference, right? So sorry, minimum difference. So for the current index 0, I'll go to these three and I'll find the minimum index, and that is what I am doing here. This loop is for that, and if nothing is executed, integer minimum value will be integer max only. In that case, I didn't find any of the um, mirror pairs, so I'm returning -1. Otherwise, I'm returning the main. Obviously, this will I guessed it that it will give TLA because it's big of n square, right? Because what if why big of n square? If nums contains all equal values, then inner loop runs for n elements. That's why it's big of n square, guys. So this will absolutely give TLA, right? Because here also we are for every reverse operation also we are giving big of digits, number of digits of that. Let's see the constraint, right? This constraint is too much, and the number of digits might go up till 9 because 10 power 9 is like 1 after 10. So 10 digits. This is like 10 n square. So this is not at all a optimal solution. And one corner case observed here. Corner case is, what if num is palindrome? It's same as its mirror image. So let's say if you have 121 comma 32 comma 121 comma something, when you are at this, you will get What you will get as list. List will be for 121. Mapped list will be 0 comma 2. Sorry, for key 121 map will be value should be 0 comma 2 0 1 2. So when you execute this 0 comma 2 in this absolute of I minus j, you are doing 0 minus 0, right, which is 0. So your answer will return as 0, and it doesn't it goes to 2. If it goes to 2, your answer will be 2, but since you're tracking minimum value here math.min, so you will always, this min will be stored 0, and you will end up returning 0, which is the wrong answer ultimately. So you should handle this by putting something like I not equal to j here, because isn't this yeah, again, this check itself is so not obvious at all, because if you see this, if I would have read this first point while reading the question, and if I would have made note of this, I maybe wouldn't I would have saved some 10 minutes of time, because when I is less than j, here itself they mentioned I less than j, and here for like this case is useless. Instead of this, I would have written I not equal to z. That at least would have yeah, that's add to the at least some optimization kind of thing, because you're not going to everything throughout everything, and mainly you will skip the palindromes here. 0 will not be considered because I equal to j. Maybe 2 will be written as answer, which is expected. Again, then wrong answer, like anyway it's wrong answer, because so the so what actually matters here, so what is the optimization that to be done here? If you observe, we want minimum of I minus j. Sorry, why j is coming? I minus j. Okay, I'm fed up with this. Okay, minimum of I minus j, right? So for cur index I, what will minimize this I minus j? J should be first appearing element, right? Let's say for this 12, which of this 21 contributes to the answer? First 21, second 21, or third 21? Obviously first 21, because if we go right and if we are finding more 21s, that doesn't contribute to my answer, because the potential number or potential index that contributes to my answer is here. So why am I even storing list here? So this declaration itself is wrong. Instead here I can put just, okay, I cannot edit, but instead of list of integer I could have just kept integer, to just show the first scene index. This is the correct word. Store key value I'll discuss. First scene index is the value. Key I'll discuss in map. Okay. Okay, listen to, yeah, and if you see the optimal solution, it's more simple, cleaner, that everyone does that. Everyone can come up with this. Anyone can come up with this. After observing that this the you should store the first appearing, the first scene index in the value as a value in a map. So I'm mapping reversed number to an integer. It's the same loop that I am going from each number. If this map contains my number, that means I have seen this number earlier. So I am getting the index of that reverse number because I am storing the reverse number in the map, and this is just This is okay. What happened? Okay, this is what they asked in the question. They just want I less than say like I minus j ka minimum value, and since I is less than j, this will be always negative, and they asked us in the question to return the absolute value of I minus j. If you see, so if it is not present in the map, I am just reversing the current number and storing it. So maybe for the so 12 comma 21 comma 21 comma 21, for this my map will be empty at I equal to 0. At I equal to 0 my map will be empty. At I equal to 1, after executing this, my current map will be 12 comma 0, and so on. Map go like this, and my since um, no, map will be 21 comma 0 because I'm reversing this. And when at I equal to 1 in this step, when I get map dot contains returns true, means 21 is already seen a reverse of something. And why am I storing the why not I am storing nums? Why not I am storing nums of I? Why am I storing reverse of nums of I? That is because of this, guys. If you observe this, I should always be less than j, and for I comma j like this, reverse of nums of I should be nums of j. So the lower index ka reverse number should be current index number. So already processed element have to be I have to be I have to make sure that the reverse of that should be equal to the current element. So that's why if you see this, I somewhere, yeah, it's like reverse of number, not the number, reverse of the number. That's because of the condition they gave here. And for this map dot contain will return true, and the j value is 1 here, and map dot get will return 0. So j minus I will be 1. So yeah, I think yeah, if you iterate also next, I will be if you go to here now, since this already contains, I'll add reverse of 21. So now the for I equal to 2, my map will contain map equal to, it already had 21 comma 0, and it'll, okay, let me put this in bracket so that I won't get confused. Now the map also has 12 comma 1, right? Because we reversed it. Okay. Now this is 2. This is now we are at I equal to 2. The map is this, and 21 is already containing in the map. Now j is 0. Sorry, j is 1, not 0. J is 0. I is 1. No, j is 1. I is 0. Correct. This should be j. Sorry, my bad. This should be j. Sorry, my bad. This also should be j. My bad. Yeah. Now when we're at j is equal to 2, so we are at this 21. 21 already existing in the map. It's a reverse of already some number. So I is 0 for this. So its absolute value is 0 minus 2 is 2. If you keep going like this, the minimum value is 1. And this is the answer for this. That is why I, after observing these two outputs, I have got the idea of storing reverse number, because if you see 120 and 21, it is giving 1, because okay, my bad, what happened, for 120 comma 21 it is giving output 1, because reverse of this number 0 to 1 is this, reverse of 21 is not 120. So you should always, that's why again this is very good example saying that why I told it here. The difficulty of step 1 is more, step 1 is the most difficult part, because I couldn't identify this, I couldn't make I couldn't give the importance to this and this. So that's how I ended up wasting 50 minutes on this question and two wrong attempts. So yeah, contest is today is pretty easy except for the third question. Usually, the second question in the contest will be of this level, and that's why if you see my rank crossed 3000 because of yeah it's like why okay again why did I make it as JE paradox. So let's say there are multiple slots, right? If you are if you gave JE after like in the COVID batch, there are many number of slots. I think it would have been some 6 slots or 8 slots if I'm not wrong. So you will be getting one of the slot, and let's say by unluck if you are routed to easiest slot, how much ever you score, 250 is not a good score because everyone would have performed very well. Same situation if you go to the hard JE paper. Even if you score 160, you might end up getting a good percentile because the paper is hard. Everyone would have performed in the same way like you. So yeah, that's why I named it as a JE paradox. Even though I solved 3 questions in this contest, the rank remains almost same as previous contest in which I solved only two because previous contest was hard compared to this contest. And the outcome of the contest should not be rank or rating because rating and rank are outcomes, right? Good point. Rating and rank are outcomes. We are not here for outcomes. We are here for purpose. What is the purpose of giving contest? Is it badge, knight or guardian? Is it rating? Is it ranking? No, this might be different for different people, but for me, the purpose is ability to make brain to think in multiple directions to come up with answer. It's not if, it is. I think when your purpose is clear, right, you won't bother that much about this. Even though I see at the rank and I know my rank and rating, it doesn't bother me. So every contest, I'll be like, I'll not. My goal, let's say before the start of the contest, my goal is not key. I have X rating. This contest should push me X plus 30 or X plus 20, something like that. That's not in our hand. So many factors matter. What is in our hand is being consistent in solving number of problems. If you are solving 2 questions and if you are able to solve 3 questions or again 2 questions in the same thing, it's fine. That is improvement. So yeah, I think this is the purpose. So yeah, that's why I don't bother how many people write with AI, how many people cheat. Like don't complain, right? Because yeah, the purpose is not getting X rating or X ranking. Just the purpose of leetcode is just to make your brain think in different directions, something like that. It's just one of the sport. So yeah, I think that's it for today's stream. Um, I had no time. I had to go out of the contest in the morning, so I had no time in reading the fourth question. Yeah. So yeah, that's for this stream, and I think uh, okay, guys, I'm ending the stream. See you in the next one with semantic search.